Hey guys, today I'm gonna look at this little Mandelbrot set thing, and also just talk about myself a bit. I wanted this to be sort of like a catalog situation, um, and obviously this is the first one, so I don't really know what's going on. Um, but yeah, I'm just gonna talk about um myself, I guess, while I play with this Mandelbrot thing. I've never actually done this before, so 200 iterations, fine. I don't know what the exponent thing means. I guess real quick, let's talk about what the Mandelbrot set is, and then I'll talk about what I do. So, Mandelbrot set is pretty much, let's say we have this polynomial, z squared, that's a pretty rough square, z squared plus c, right? So, the point is that we can take iterates of this, right? So you can do like p of z, right? And you can keep iterating. Now, specifically, the Mandelbrot set is defined as those c such that I guess we'll say for all natural numbers, um, Pn of 0 is bounded. Okay, cool. I'm pretty sure that is maybe not the most common definition, but it's probably the easiest to understand, right? For instance, we know that c equals 0 is in the Mandelbrot set because p of 0, if c equals 0, well, p of 0 would just be 0 plus c, but c equals 0, so that's 0. And then the second iterate is just also going to be 0 and so on. So certainly 0 is in the Mandelbrot set. And I won't go through all examples, but it turns out that there are many numbers where that's not true. In fact, most numbers, most values of c will make this not true. For instance, like c equals 3, for instance, will definitely not work, right? If we do that real quick, p of 0 equals 3, since it's 0 squared plus 3. And then the second iterate is effectively going to be p of 3, which is going to be 9 plus 3, which is 12. And we can quickly see that this is going to blow up. It's not bounded. So this means that c equals 3 is not in the Mandelbrot set. So that's kind of why it looks like this. Yeah, I don't know if I can like zoom in or shift plus drag. Drag what? Oh, okay. Oh, okay, cool. That's pretty cool. Okay. So yeah, just a bit about me, I guess. Um, I'm Matt, or I guess Matthew. Um, I'm a math major at one of the, one of the big universities, I guess. I mean, I don't know. It's not that big. I mean, most people outside of the state probably don't know it, but it's pretty well known. And my field of study is complex dynamics, which is stuff like the Mandelbrot set. And ultimately, I think what I'd like to do is get a job in industry, so make a lot of money, right? Um, and then, I don't know, do like research and stuff, right, when I'm older. This is really cool. We have this kind of like, I think it's called a baby brat, right? Where it like looks kind of like it looks like the Mandelbrot, but it's like really small. Because remember, this is the big Mandelbrot. But then you zoom in on this like random baby brat, and it's kind of the same exact thing, which is really cool, I think, that you get this kind of recursive look going on, right? That is the whole point. I don't know what's going on over here. Let's see. This is quite an interesting shape, little curvy spiral thing. So yeah, that's a little about me. Specifically, the industry sort of field that I'm looking at right now is called quantitative finance. Exponent. Oh, it's probably like z cubed, right? Like for instance on Paint we had like this is like z squared. I'm guessing that this is changing the exponent, which no longer I guess is really the Mandelbrot set, but it's just a larger family of functions. Can we do, I'm curious, can we do like a decimal? No. Okay, so I think it takes the floor of whatever you plug in. 24. Oh, shoot. No, definitely not 24. Let's look at like 4. So this is really interesting. It's kind of like a fat Mandelbrot. That's pretty funny. Um, but let's go back to the original since that's, the famous guy. And so, yeah, right now I want to get into Quant, or just continue my math research. I think either is fine by me. Um, right now I'm doing an internship, which is pretty fun. Um, it's about factor models. Pretty much the idea is that, let's say you have a portfolio of stocks. You want to pretty much have a risk assessment, right? And figure out, how pretty much like what happens if something really, really bad happens, right? You want to figure out how bad it can get for your portfolio if really big events happen. Um, and what factor models are is pretty chill as well. I guess why is nothing erasing? Okay, cool. Factor models is pretty much the idea that you take some returns. Doesn't have to be a stock, right? It can be crypto, whatever you want. Okay? And you want to try to explain the returns of the stock using a few things, right? Maybe you want some market factor. This can be like SPY or like SPY excess or something. So that's one. Another common one is a growth factor and a value factor. And these are all different types of things that are more general market indicators. Yeah, and maybe you'll get like some, like whatever, what do you want to call it? Whatever specific, I'm blanking on the terminology, like Apple is like a text, the sector, right? Maybe you want like a sector proxy as well. So stuff like that. And the point is that you want to decompose your stock returns. And I mean, it's really not quite explaining stock returns, but that's kind of a simple way to think about it, maybe. Um, which is that you're explaining your returns using these different outside factors. And you can do this with like a linear regression or something. The kind of fundamental equation, I think, is pretty much that we can explain our returns. So I guess we'll call our returns RF. And the idea is that it's some alpha, which I'll explain in a second, plus the sum over our factors and their respective betas, which I'll explain, plus this epsilon or like noise term. So all this is saying is pretty much that our returns of a stock can be decomposed into 3 separate components. So this guy here, this middle term, is probably the most interesting. And effectively, all it is this is the part of our returns that is that explains. Okay, I don't think writing it out is going to be too prudent. Let me type it out. Where's the text box? Explains. Yeah, this is the part that explains market returns, right? Let me jump this up a bit. Yeah. So that's what that guy does. Then alpha is, and you might have heard that if you've heard any like quant terminology, right? Like this strategy has alpha or something like that. It's pretty much the the excess that's not explained by current factors, right? And the theory with this, because that might not make, sense why that matters, the theory is that if you had all the factors, if you had all the information, you could explain the alpha. But because you don't have all the factors and you only have, some finite collection that is, not perfectly efficient, that means that there's some excess still waiting to be explained. And we call that our alpha, right? We want to find how to extract that alpha. And then the last guy, this epsilon or noise term, is just pretty much that random, sort of that, these random shocks that can happen. Random shocks can't, we'll say we can't predict them. Because we can't. That's kind of the theory. Okay, that's annoying. Can you not do that? Really, the bottom got cut off? Okay, whatever. Jesus. Okay, this is rough. Can't predict them. Okay. So that's what this guy at the bottom is. Okay. So this is kind of the basic idea behind a factor model. So I think it's really interesting stuff. What else? What other important stuff is there to say? Let's do like 10 iterations real quick. Whoa, that looks slightly less cool. 5? Oh. Yeah, okay, so we're kind of getting it back. But there's definitely not like less clarity when you zoom in, probably. I don't know, 50 is kind of giving us a lot. Yeah, I think we would get more like in these areas if we zoomed in, these kind of spline looking things. I like playing chess as well. So that's cool. Right now, I'm gonna do, so this is funny. So I have this friend of mine that's really, really good at like discretionary trading. He trades on like Kalshi, which is just, one of these exchanges. But he doesn't know like any math really. He does. That's a silly thing to say. But he doesn't know like quantitative, like quant math, right? He doesn't know like probability and stuff. Um, and so what I realized was, wait a second. I know that stuff, right? I know like the machine learning, like that sort of like, like the models and stuff. I've implemented stuff with papers. He's the guy that actually knows how to go on an exchange and trade. So wait a second. Why don't we work together? Why don't we work together and make like an actual strategy? Um, that we can actually trade, right? Because he knows how to do that. Um, he knows how to do that in a discretionary sense, and I know how to do that in an algorithmic sense. So why don't we kind of put that together, right? We both thought it would be like, a pretty awesome resume builder and stuff. Um, and just a fun thing to do as well. Because at the end of the day, if you can trade profitably, why not, right? Um, so yeah. Is there anything else I want to say? I guess that's a nice introduction. Yeah. Hope you enjoyed.